Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic aromatic substitution, EAS, rates are governed by the electron density of the aromatic ring. Electron-donating groups, EDG, activate the ring and increase the rate of EAS, while electron-withdrawing groups, EWG, deactivate the ring and decrease the rate. Moving on to the next step. Reaction A, toluene with SO3H to SO4, sulfonation occurring at the meta position. The methyl group is an EDG, activating group, via hyperconjugation and induction. Even though methyl is ortho-para-directing, sulfonation can still occur. The product shown is meta, but the rate of the overall sulfonation of toluene is still faster than benzene. Toluene is more reactive than benzene due to the electron-donating methyl group. Reaction B, toluene with SO3H to SO4, sulfonation at the ortho position to methylbenzenesulfonic acid. This is also sulfonation of toluene, same substrate as A. The methyl group activates the ring. Ortho-para positions are most activated. The rate of toluene sulfonation is faster than benzene. Reaction C, nitrobenzene with SO3H to SO4. The nitro group, number 2, is a strong EWG, deactivating group, via resonance and induction. It strongly deactivates the ring, making EAS very slow. Meta product is obtained consistent with EWG meta-directing. Moving on to the next step. Both A and B involve toluene, same substrate, just different regiochemical products shown. Since the methyl group is EDG, toluene reacts faster than benzene and much faster than nitrobenzene. Reaction B gives the ortho product of toluene sulfonation. Reaction A gives the meta product of toluene sulfonation. Since methyl is an ortho-para director, the ortho-para positions are more electron-rich and more reactive. However, A and B use the same starting material, toluene, so the overall rate of sulfonation for both A and B is the same. The difference is only regioselectivity of the product shown. Weight re-examining, A gives meta product from toluene, B gives ortho product from toluene. The rate referred to is the rate of the overall reaction for each substrate. Since A and B are both toluene, their rates are equal in principle, but the question asks about the rate of each specific reaction as written, forming the specific product. The ortho position, B, is more activated than the meta position, A, by the methyl EDG, so B A in terms of rate of forming that particular product. C involves nitrobenzene, which is strongly deactivated slowest. And for the final step, C, slowest, deactivated ring, A, toluene, meta position, less activated, B, toluene, ortho position, more activated by methyl EDG. Increasing rate, CAB, which is equivalent to BACB, BCA, wrong, C, nitrobenzene, cannot be faster than A, toluene meta. C, ABC, wrong order between A and B, ortho, B, is more activated than meta A. D, ACB, wrong, nitrobenzene, C, is deactivated and cannot be faster than B. Therefore, the correct answer is A. Therefore, the correct answer is option A.